Hello, everybody. Happy Friday. I'm guessing most of you will watch this on Friday, although I suppose if you procrastinated, you might be watching this on Monday, or maybe you're watching this again because it was so good and you wanted to review before the test or something like that. But either way, I hope you're having a good day. Today, we're going to take a look at lateral area and surface area, but I wanted to clean up a little bit of um, terminology before we get to that. We've seen this slide already. A prism is a three-dimensional solid. All of the faces are polygons. And if something is a prism, that means two of the bases are on parallel planes. And that's what I kind of want to focus on first. If I have a prism, both of these are prisms. This one has a triangular base, it's a triangular prism. This one's a rectangular prism. Each of the bases is a rectangle. And if something is truly a prism, that means if you slice it, if you think of this as a giant block of cheese or something like that, if you slice through it, the cross section that you create is going to be the same anywhere that you slice it. And it should be the same as both of the bases also. So you could think of slicing off a little tiny, uh, a slice of cheese, or if I cut this thing in half, the cross section that you create should be the same regardless. Some terminology that you may have noticed on the assignment that's due today. I use the word right, and we've seen right in terms of angles, a right angle. But if I say that I have a right prism, what I mean by that is that these sides, the sides that connect the bases together, have right angles, which means these are all rectangles. These look like squares to me, but a square is a rectangle, so that's okay. The other word that means not right is the word oblique. Oblique means you got two bases. This is still a prism because if I slice this thing, no matter where I slice it, I create that triangular cross section. This one's oblique because this face, this lateral face, which we'll talk about in just a moment, is not a rectangle. You could think of it as the base is not straight up from the other base, but it's off to the side. The word lateral that I just used, here's our big focus for today. When I say find the lateral area of a prism, and eventually of a pyramid or a cone or something like that, but if I refer to the lateral area, I'm talking about the combined areas of the faces that are not bases. Some of you might think of this as finding the area of the sides. And so if this is one base up here and this is another base down there, then I'd be finding the areas of all of these rectangles that make up the sides. That's the lateral area. If I just say find the surface area, or sometimes I'll refer to this as the total surface area, that means we're finding the area of everything. So basically, the easy way to do this is if you've already done the lateral surface area, the lateral area, take whatever you've got for that and then add on the two bases. And in this case, they'd be rectangles. Sometimes they'll be triangles. Sometimes they'll be trapezoids. Many, many, many times, especially on your tests and quizzes, I'll say find the lateral area, surface area, and volume. We're going to do that on Monday, but the volume is something that we'll talk about a little bit later on. So if I say here is a shape, I've got this rectangular prism, and I say find the lateral area and surface area. These will be the abbreviations for those, lateral area and surface area, where the bases are measuring 4 inches by 5 inches. And so it really doesn't matter which goes where. I'll put the 5 here and the 4 there. It looks like this side is a little bit longer than that side. So I'll go with 5 and 4. And then the height is 8 inches. This is why you had the assignment that you hopefully did last night. I'm going to draw a net for this shape. I'm going to lay this thing out. I'm going to take the 4 lateral faces, the 4 sides, and lay them out end to end. So you could think of that as the left side, and then here's the front. Here's the right side, almost like we're unfolding a cereal box here. And then the back side. And then I've got the flap on the top over here. And then I'll put the other one down here on the bottom. And so as I'm thinking about these faces, these lateral faces, the prism has a height of 8. So this dimension is 8, at least on my net. The top is 5 by 4, so if this side length is 5, then the one next to it has to be 4. If this is the front, then this is the back, which is the same width, and the left side and the right side are both the same also. And then this side here matches up with this side here because those two were together. The top of the right side matches up with the right side of the top. And so if this is 4, then this has to be 4. Same thing down here. This is 4. These are both 4. This side is 5. All of these sides are 5 because these are all rectangles. And I suppose I don't have to label everything. In fact, I think I've got enough labeled that I'm going to be able to figure this out. Now, when I say find the lateral area, maybe I'll do this in red. The lateral area, that'll be this one plus this one plus this one plus this one, all 4 of these sides. And you could do 4 times 8, 5 times 8, 4 times 8, and 5 times 8 and add all 4 of those together. Or I'm going to think of this as one great big rectangle with a height of 8 and a width of 4 plus 5 plus 4 plus 5, 18. So my lateral area, I'm just going to do 18 for this total length here times 8 for the height. I'll just pull out my calculator and do 18 times 8, and I got a total lateral area of 144. And then so we'll do the surface area in blue. The surface area, well, I already found that the lateral area is 144. So I'm going to take that 144 that is my lateral area, and I'll tack on the area of this base plus the area of that base. They're both the same thing. Oops, I'm not sure what happened there. But I'll just add 2 times the area of the base. Well, this base is 4 by 5. This one's 4 by 5 also. And so each of those bases is an area of 20. And so there we go. My total surface area is 144 plus 2 times 20. 144 plus 40 is 184. These were inches. So these areas, both lateral area and surface area, these are both in inches squared. So lateral area of 144 inches squared, surface area of 184 inches squared. Total surface area will always be bigger than the lateral area because it includes the lateral area. All right, there we go. That is a rectangular prism. Let's move on. Let's take a look at this triangular prism. This base is a right triangle. This base is also a right triangle. Of course, they have to be the same. And then the height, the distance between the two bases is 5. I'm going to lay this out as a net again because this is going to help me visualize what this thing looks like. I'm going to draw it this way. So these are all 3 of those faces, the bottom of it here, the left side over here, and then the top of it. These are the 3 lateral faces. One of them is 10 units wide. One next to the 10 is 6. And then next to that, we've got 10 and 6 and 8 next to that. So my lateral faces are laid out in a rectangle that looks like that. The bottom and the top, these are both triangles that are 10 by 6 by 8. And so if this is 10, then I suppose it could look something like that. I do have a right triangle, so maybe I'll keep track of where that right angle is. This matches up with that, so this must also be 6. And then if I fold this thing over, this side is going to match up with that side. That's coming from this section right here. That side must be 8. And then I'll have the same triangle down here on the bottom. This side is 6. And that side is 8. Oh, and I better label this. The distance between the two bases is 5. So that is that distance there. Lateral area, again, I'll do this in red. The lateral area is going to be the area of these 3 faces together. The height of 5 and a base of 10 plus 6 plus 8. So 24 times 5. I'll plug that into my calculator and find that's 120. Again, that comes from 5 times 24. So I got a lateral area of 120. These dimensions are in centimeters, so this must be 120 centimeters squared. And then my total surface area, we'll put that down here. My total surface area will be the lateral area, 120 centimeters squared, plus I've got two triangles. I'll always have two bases, so I'll add 2 times the area of this base, and that one will be the same. And they're triangles, so base times height divided by 2. Where's my base? Where's my height? Well, maybe you remember from a long time ago, the base and the height are perpendicular. So my base and my height must be 6 and 8, or 8 and 6. So my area of a triangle is 6 times 8 divided by 2. There we go. 2's cancel out. I'll have 120 plus 48. We'll get a total of 168. And again, everything is in centimeters, so it's 168 centimeters squared. So there we go. All prisms work the same way. Really, the only difference is sometimes you got triangles, sometimes you got rectangles. I think one of the problems in your assignment, you're going to have a trapezoid. So you'll have to look up the area of a trapezoid formula from your notes, or maybe you already remember it. So let's finish up with this. This is a cylinder. We've referred to a cylinder yesterday. I'm sure a lot of you know how a cylinder works, or what a cylinder looks like, I should say. So if I'm looking for lateral area and surface area for a cylinder, this isn't a polygon. This isn't a triangle or hexagon or something like that. This is a circle. So I've got a circular base. And so if I think about laying this out flat, if I make the net of a cylinder, I'm going to cut this thing straight down the side. I'm going to try to cut it as straight as I can down the side. And then if I unfold this curved part of it and lay it out flat, that part is going to leave me with this rectangle. And so I've got a lateral face that looks like that. Again, this is the curved part of this. If you think of it as like a roll of toilet paper, something like that, the little cardboard thing on the inside, if you cut right down the side and then lay that thing out flat, you make this rectangle. Now the height of the cylinder will be the same as the height of that rectangle. And then the tricky part is, what is this distance, the distance across this lateral face? Well, that is coming from this distance all the way around your circular base. And we've got a name for that. The distance around a circle is the circumference. And so if I know what the radius of this shape is, or if I know what the diameter is, this distance is the circumference of the circle. So you could call it the circumference. You could say that that's pi times the diameter, because that's how we defined pi. Or if I've got the radius, I can say that the diameter is the same thing as 2 times the radius. So pi times 2 times r. So any one of these is okay. It depends what you've got, but that is that distance. And then of course we'll have the circle on the top, the circular base on the top, circular base down on the bottom. Sorry about those sloppy diagrams. But then I'll have the area of that circle and the area of that circle when we're doing the total surface area. Now, because it always looks the same, because we have formulas for these, I'm actually going to put the formula, and I think I'm going to switch over to my text tool so I can do this a little bit more legibly. My lateral area is equal to, well, that's the area of that rectangle. So it's the height of the cylinder times circumference, which I guess I'll call it the circumference, or maybe you could call it the diameter times pi, or maybe you say that that's the height of the cylinder times pi times 2 times the radius. Any one of these is okay. circumference of the circle times the height, circumference of the circle times the height, circumference of the circle times the height. And then finally, for the surface area, I'll switch to a different color so we can see the difference between these. The total surface area will be the lateral area plus 2 times the area of the base. And of course, the area of the base is pi times the radius. I better use this, pi times the radius squared. So lateral area plus 2 of the bases. And there we go. There's your formula for a cylinder. So if I want to do the lateral area and the surface area for this cylinder, my lateral area, well, let's be consistent. Let's make that red. The lateral area will be the height, 10, times the circumference of this circle. Well, if the radius is 4, that means the diameter is 8. And so the circumference will be 8 pi. So if I want to leave this in exact form, it would be 80 pi. If I want to plug that into my calculator and get an approximation, 80 times pi, I get about 251.3. 251.3 units squared, whatever the unit is, centimeters, inches, or whatever that is. The total surface area, this will be my lateral area, plus 2 times the area of the base, where the area of the base is pi times the radius squared. My radius is 4, so pi times 4 squared. So my exact answer, my lateral area I found already was 80 pi. And I've got 2 times 16, I've got 32 pi. And 80 pi plus 32 pi will be 112 pi. That would be my exact answer. If I want an approximation, I can plug that into my calculator. And I'll get my squiggly equal sign. When I plug this in my calculator, I got about 351.9, again, units squared. So there we go. Thinking of it in terms of the area of a rectangle, or if you want to plug it into a formula, that works as well. The last example I want to do, one more cylinder. Let's do a real world problem. I had a can of Diet Coke earlier, and so I got out a ruler and measured it, and it wasn't exactly these dimensions, but it was close enough that this will work out pretty well. Now, a can is actually not exactly a perfect cylinder because it's got some indentations on the side and on the bottom of it also, but let's just call this roughly a cylinder. The actual surface area won't be too much different from what we find here. The height is 12 centimeters. That's the height of our can. That's the height of the cylinder. And I measured it to be about 6 centimeters wide. It was a little bit more than 6, but I'm going to use 6 for that distance. So that's the diameter of the circle that's on the top. The radius is 3 centimeters. The height of the cylinder was pretty close to 12. I think it was just a little tiny bit less than 12. So a little bit of an overestimate on top, a little bit of an underestimate on bottom, but that's okay. My lateral area will be the height of the cylinder, 12 centimeters, times the circumference of the base. Diameter is 6, and so my circumference is 6 times pi. So I get about 72 pi. This is a case where an exact answer doesn't make a whole lot of sense because I've got measurements and I've got a real world problem. So I'll plug this one into my calculator and find that 72 pi is about 226 square centimeters. So if you took the curved part of a can of Coke and laid it out flat, you could fit about 226 centimeters squared on that surface. And finally, my total surface area is my lateral surface area that I just found, about 226 square centimeters, plus the area of the bases, I've got two of them, so I'll take 2 times the area of a base. If the diameter is 6, that means the radius is 3. And so the area of one of the bases is pi times the radius squared, pi times 3 squared. And when I plug this into my calculator, I'll just add 18 pi onto my previous answer. Whoops. Sorry about the delay. I plugged something in wrong on my calculator. I think that looks right. I got about 251, well, about 251.3. So I'll just call that about 251 square centimeters. I think rounding to the nearest square centimeter is pretty appropriate for a problem like this one. So there we go. That's a few examples. As you're doing the homework tonight, you'll notice that a lot of the shapes are the same. In fact, they're copied from the assignment from last night. In this case, you'll be asked to find the lateral area and surface area. I've crossed off some shapes that we don't know how to do yet. We haven't talked about how to do a pyramid yet, so I crossed those out. And a couple of the problems were really similar. I think I crossed off about 5 of them because there was a little bit more repetition that I wanted. So take a look at that. If you have any questions, get a hold of me. Otherwise, I will see you next week or see you next time I check in with one of these videos. Have a great day, have a great weekend, and we'll see you next time. Bye-bye.